Those moving lines you see there are radio waves visually. You see them as patterns on our oscilloscope here. Or I can pick them up as sound through the shortwave radio, and you can hear the sound. Now that may sound like static, and it is, but a very special kind of static. It comes from the planet Jupiter. It was recorded originally by a radio telescope. The radio telescope is one of astronomy's newest and most powerful tools for exploring the universe. The one you see is the largest in the world. It is directed toward the heavens, toward a spot in the heavens, and it picks up radio waves from, well, for one thing, nearby planets like Jupiter in our own solar system. And then it probes outside of our system and records radio waves from the Crab Nebula here in our galaxy. And it reaches beyond our galaxy to other galaxies in remote parts of the universe. Picks up radio emissions from a source where actually nothing is visible. These are sounds from space. And a fair question, is a message from some far-off person or beings like ourselves buried someplace in that static? That question has been asked many times, and today, for the first time really, scientists are in a position to investigate that age-old question. The question of, is there other life in the universe? Is there other life in the universe? Is a familiar question. I think you've asked yourself that one. All of us have. We usually think of life as being more or less like ourselves. We're made out of things like this. This is a model of a molecule which is built of atoms, mostly carbon, hydrogen, oxygen, three basic ones and others too, into molecules, and from there on life on Earth is built on these elements. Astronomers have found these same molecules, or at least atoms, in space, way out there. So consider for a moment what the essentials might be which would be needed to start a cycle of life and evolution on some other planet, far out there in space someplace. First, our hypothetical planet would have to have a sun. That was the source of the heat, the radiant energy which makes life possible. However, not just a sun, but one which is the right size and temperature for the distance from the planet which we're talking about as the source of life. A too small sun, you see, or one too far away wouldn't provide enough heat and energy to produce and sustain life. And on the other hand, if the sun were too large or too close to the planet, it would be much too hot there to let the molecules get together and begin life or evolution. These solar flares are the kind of heat that I mean. So for life to evolve, the planet must be large enough to have gravitational pull to keep its atmosphere, as the Earth's, which you see here briefly, from escaping into space. And the hypothetical planet must have also lots of atmosphere with some water in. Presumably it's in the atmosphere or it's on the surface of the planet like this. Enough water at least, and temperature enough to keep it from freezing and boiling. Either or. Well, that's a mess of limitations, you might say. So what are the chances then of really finding life as we know it, or any kind of life for that matter, someplace in the universe? Start please with the chances of life in other parts of our own solar system. First, there is the sun, which, as you see here in that film, close up to the sun, is a whirling, intensely hot ball of gas. Surface temperature, 10,000 degrees. Life as we know it is not possible there at all. This is our friend the sun here. The nearest planet is Mercury, right over there, a little one. And life isn't too likely there because Mercury faces the sun all the time as it goes around. It looks right at it, and one side's very hot, and the other side is very cool. It points away, and it's always dark. Pardon me while I move the Earth here. The border zone of Mercury we won't bother with, not likely. Venus, who is very bright at night, hello there. Venus is not too close to the sun, not too far away. It's a probable place. Astronomers thought for a while that Venus might have life on, but recent findings show that its temperature is just a bit too hot. Life there really is very unlikely. And now that gets us to us, Earth. We have life, we're pretty sure. And our nearby neighbor, where's Mars today? Here he is, over here. He's going around, you see, and after a while he'll be over and very close to us. Mars is a candidate for life. Pretty good one, really. Has a thin atmosphere, and by our standards, it's not unseasonably cold or unreasonably cold, either one. In this picture here, which you see through an actual telescope, the polar ice cap gets smaller and smaller at the top as it shrinks and melts with the approach of Martian summer. The dark patches which you see developing now are thought to be Martian vegetation, which appears during the moist season after the polar ice cap is melted. That's the planet which we're getting closer to in every way, every day. Then out beyond Mars, well, the chances of finding life become really progressively smaller as far as you go. When you get to Jupiter out here, it's very big, has a thick atmosphere of very cold gas. This photograph through a telescope shows you the bands of gases around the planet, very cold, way below zero. Life is not very likely on Jupiter, nor for that matter on very handsome Saturn. Saturn has a lot of beautiful rings, but much of these gases, hydrogen, methane, ammonia, in fact, the ammonia is in crystals, it's so cold on Saturn there. And further out, you have Uranus and Neptune over there, and where's Pluto? Here's little Pluto way out there. Far too far from the sun, far too cold. These are not in scale, or they'd be in central Montgomery, Alabama, I think. Probably then, there's no life in our solar system beyond Earth and perhaps on Mars. But our sun is a star, you know. Rather a second-rate star, but the best we have. But there's so many other stars, and maybe they have planets, too. And you know, on a clear night, without a telescope, you can see between 2,000 and 6,000 stars with your naked eye. And with a good small telescope, you can see millions of stars. And with a big one, well, it's hard almost to say how many. And the largest telescope in the world at Mount Palomar, when you look through that, you go billions of light years into space, and you see on photographic plates billions of stars and billions of galaxies composed of billions of stars. And perhaps as the diaphragm opens there and the observer in his cage at the prime focus of the mirror begins to look upward as the sun goes down, and he looks out toward the edge of our galaxy, the Milky Way, one of the millions of suns there has a planet which is suitable for life. But how likely is this? Is man unique is the question that each of us has asked, and I think we can ask now the man who is most likely in the world today to know the answer to that. He's Dr. Harlow Shapley. Dr. Shapley, of course, is one of the great astronomers of all time, if that's not too sporting a term, Doctor. I believe there were the early Greeks and Copernicus and yourself who put us...
put us in your places.
Well, Dr. Shapley did put us in our place. The Greeks thought that the center of the universe was the world, and then Copernicus put it in the sun, and you put us in the galaxy, and then out in... Where is the center of everything now?
Center of everything, I don't know what the words mean anymore. We've got to the place where nothing has a center.
I asked that question a minute ago. Let me repeat it. Is man unique in the universe, do you think? Chemically, say?
Unique in his chemical composition? Not at all. No, he's very common on it. Well, for this example, you know, elements like hydrogen, carbon, nitrogen, oxygen, they're very important elements for life. What is it? About 9/10 of the ocean is one element, oxygen. And the crust of the earth, half of it is oxygen. And the atmosphere, nearly 22% is oxygen. And you are 2/3 oxygen, so you're made of the same stuff as the stars and the galaxies, as well as the planets that we spoke about, or the phenomenon on the surface here.
It'd be rather strange if I were unique then with all these...
Well, it'd be very embarrassing, I think, to us, because there's no uniquity left over. We know all about all the elements, and there's no other queer element that you could be composed of.
What are the odds, then, that there is life, statistically derived?
Oh, the odds that there is life, I think, is very high. Others think it's even higher than I think, and I think rather boldly in it. But here is the point. There are 10 to the 20th power, that's a shorthand way of saying 100,000 million billion.
Is that 10 with 20 zeros after?
Yes. 1 with 20 zeros after. Well, there are that many stars, and all those stars have the potentiality of having warmed up planets in the right zone that you spoke about, so you have liquid water. And so I'd say that even if only one star in a billion had a planetary system, and only 1 in 1,000 of those had planets in the right place for the liquid water and so forth, whittle it down as much as you can, you would have then about 100 million planets where I would say high life exists.
High life as we get.
Yeah, high life as we get. I mean, elevated life, not just the lichens, not just the algae.
Well, how did this get started? Isn't there a great gap between the most complex organic, inorganic molecule and the simplest form of life? Isn't there a gap in there?
Well, there was thought to be over a good many years, but in the last 10 or 20 years, we see evidence that, of course, we're all one stream, that there's a cosmic evolution that's gone through the universe, from the hydrogen atoms through the rest of the atoms, through the molecules, into organisms, through all the organisms, all the way up to us.
How is this determined? Is it still going on, this experiment?
At the present time, I wouldn't say that life, so-called life, originates easily, because it'd be a little difficult here on the surface of this planet. But there's no question at all, but the evolution is going on all the time, as it has in the past. New stars are being born, new galaxies are coming into existence, and new opportunities for this biochemical operation that we call life.
We're speaking, when you say life, is life as we know it on other planets.
That's right, life as we know it, life based on those elements, those atoms I mentioned before, especially carbon and nitrogen, oxygen and hydrogen, yes, that kind of life.
Isn't this kind of limiting us? Couldn't it be life based on silicon and something else?
Yes, that's right. We're a little, we take ourselves seriously and think that our kind of life is what could exist. But often it's been suggested that instead of having carbon, we could have silicon. And instead of some other element, we get some substitute and still could have a living organism. But the best biologists or biochemists that I know say, no, that isn't the way it's going to work. There's a universal biochemistry, and the biochemistry we have here that we call life is the same, generally it's the same as they would have elsewhere.
They could be surprised sometime, I presume.
We could, yes, we could be surprised. We have so many kinds of life, though, already, 1 million kinds of life on the surface of the Earth.
Very different than you and me,
well, yes.
Big and small.
There are more than 200 kinds of beetles and 1 kind of man. Yes, I'd say we're rather unique in that way as we got by. And
how hot can life be and still have people?
I don't know. When you, as you said a bit ago, when it boils away into a vapor, hot vapor is no place for protoplasmic adventuring. And when it's frozen, no, we want water in a liquid state.
Don't creatures live in the hot springs out in the Yellowstone?
Oh, a bit, yes, but they're not hot the way a star's surface is. Not the 10,000 degrees of the sun's surface, no.
Would you say we're the most complex form of life any place, or are there possibly
I think it'd be much more complex in a lot of other places. There's no reason why we, on this little planet around a run-of-the-mill star at the edge of one galaxy, would be the place where the topmost of anything would happen. No, I think they've probably been excelled easily in a lot of places, but we're out of touch.
For the time being, do you think we may get in touch sometime?
Well, I'll leave it to you. You're going to take
I'm
that
going to leave it to Dr. Morrison.
Yes, I see.
Though, speaking of the other possible lives which do exist, if we were to reach them, I'm going to ask this question of Dr. Morrison, too. What could we hope to learn to improve the human condition here?
Well, on the way out, and without getting far out, we'll learn by our new techniques a good deal about our Earth, and a good deal about our atmosphere, and about electric conditions around here. And so the byproducts for the first year or two of travel toward another star might be very rich in just improving knowledge. And that, of course, helps mankind.
The other planets could be 1 million years older than we, for example.
Oh, a lot of them. We could be considered. We think we're about third generation sun and all. And there's some that must be a good deal older than that, and of course, a great many young ones.
Well, think what you yourself in one generation have taught us and how much we have for another 1,000 generations.
Yeah, you have a lot of time to undo what I've told you, yes.
They out there do, too.
Yes.
Thank you, Doctor, very much.
Well, thank you.
See you in a few minutes. So out there in the universe, as Dr. Shapley in Men and Stars predicted, there must be, by reason, 100 million planets which have life on as we know it. This is pretty startling, but it's as true as 2 and 2 being 4. It's pretty doubtful, too, that we as humans will ever travel, actually, beyond our solar system to come even to the closest of them. If you look out with a telescope or with your naked eye, you see a bright star, if you live in the south, called Alpha Centauri, our nearest neighbor star. But to go there, it's quite a trip, more than 25 trillion miles away. Traveling at the speeds of our present spaceships, it would take thousands of years to get there. The original crew of that spaceship would have lived out its life, and a new crew been born and lived out its life, and more generations. The journey would be completed by descendants maybe 15 or 20 generations later. So don't plan on leaving for Alpha Centauri or even Proxima right away. Someday, though, a better idea may work. We may be able to contact them by radio, and they may be able to reach us. In fact, perhaps they are now. The tool for communication exists in this, which you see here, the radio telescope. It's only a few years old, but as a radio telescope, it looks out into space like this at stars, galaxies, and objects which can't be seen beyond the range, perhaps, of optical telescopes, or hidden from view behind dust clouds, as you see in the center here. These dust clouds, this black streaks there, are the center of our own local galaxy, the Milky Way. The dust clouds are cosmic dust, behind which are many stars and points of radio emission. The signals which you hear in the background now come from that area. And astronomers who are reading them here, or looking at them, reason something like this: intelligent beings out in space may well have invented radio transmitters. We did, after all. And if they did, perhaps they're trying to get in touch with us. And so a few courageous pioneers have listened to this static from outer space, begun to analyze it, and hope to find a message in those signals. It's a perfectly sensible thing to do. It's a kind of a miracle that hasn't done before. And one of the men who did it is with us right now. He's Dr. Philip Morrison. Dr. Morrison is a theoretical physicist at Cornell University and a man with an outgoing imagination. Dr. Morrison, these radio emissions or transmissions which we heard, are they like radio broadcast waves that we get from local stations?
They're the same sort of wave. Your set, radio or TV, picks up the deliberate signals from stations, but it also gets the ignition noises and the lightning storms. Natural, or let us say not deliberate forms. That's what we hear now, the natural radio emissions from the electrons of space. We hope buried beneath them somewhere might be a deliberate signal.
You imply then that in these signals which are buried in here is the existence of people as advanced as we are in some ways.
Beings, let us say, as advanced as we are, technologically, I should think, most likely very much more advanced. The time that we have known radio and radio telescopes is tiny on the scale of the age of the Earth.
1931, was it?
You know, something like that. And radio itself is only 50 or 100 years old. We have no senses for it. There's no natural source radio of any great strength on Earth. And we expect that beings who have evolved over billions of years have no reason to be just in step with us. Therefore, they're probably many, many years ahead. And if somewhere they have had the same kind of history as we, they will be technologically far more competent than we are.
Well, where should we look? These telescopes look out toward specific points, don't they, stars?
Yes. The distances are so enormous, as you know, that the transmitter would be dwarfed if it were not directional and beamed like a searchlight beam. Thus, the radio mirrors, which look rather like giant searchlights, which are radio searchlights. You have to point those at the right star, around which is the right planet, with the right beings anxious to beam toward us. Now, those stars, we will say, will probably be stars rather like our sun. There are plenty of them. Dr. Shapley mentioned that. I think he's very conservative. In our galaxy alone, there are 100 million stars close enough to the sun to be the hosts for life.
Well, that will do as a start, anyhow.
That would do as a start.
We look at one for, or listen to one for how long before we know there's a signal in there?
Oh, that depends on your receiver and in many circumstances. We have to try to find out the best way to listen, and then we must search one by one with our best means, and then probably not give up, but search again with still better means when they're improved, and so it will go.
Well, I heard about Project Ozma. Is that doing that?
These people began the first job. They bravely tried to look at just 2 out of the 100 million stars, and they didn't find anything. But you wouldn't expect to find a needle in the haystack the first time you look.
No, not exactly. What kind of a message, though, do you hope to find in the signals? What will be there?
I think it's pretty clear how to decipher the message. Don't forget, if the message is there, it will be a message aimed at people like ourselves, beings like us, who will try to understand it. Therefore, it will not be complex. It will be made as simple as possible, spelled out how to decode it on the face of it. We don't have experience with messages like that, but there must be some. You would begin to think of simple arithmetic. We can recognize that. Then the signs for plus, minus, and so on. Then more complicated formulae. And from this we can show you could make television pictures, how to decode television pictures.
Yeah.
And I think they're coming over, you know. There'll be TV pictures in pulses, which we'll slowly have to learn how to decipher.
They would send the TV pictures and then a little information on...
Right, a primer on how to decode them, and then a little more new picture, and then a primer and a new picture. So anytime you tune in, you don't have to wait very long for the primer to tell you what you're seeing.
The first open-end program.
Yes.
Do we have radio transmitters now powerful enough to signal back?
Almost so. I think it could be argued that we could. But first, let us hear the signal, and then we will certainly bend our greatest efforts to answer it.
It would be 10 or 20 years one-way message, wouldn't it?
In the closest case, it would take us 20 years for a two-way conversation.
Well, we're not going to be rushed into it then. Good.
No, it's better to listen for a long time. There may be some very good programs coming over.
Dr. Morrison, I hear the word convergence used in connection with you a lot. What's convergence?
I think the idea is quite a simple one. People ask, how could it be that beings far away in a different planet, in a different world, would come to the same sort of technology that we have? And the analogy that I would like to give we can see here in the animals of our own Earth who have by natural processes evolved. For example, long ago there was a fossil reptile. You see him there. He swam in the ocean 300 million years ago. Look at the shape of that fella. Beautifully streamlined, suitable for swimming. And nowadays we see an animal which was descended from land animals, the porpoise, who swims in the ocean very well too and has a shape, look at it, not so different from that reptile. Yet this animal is not descended from that reptile in any way. He comes from land animals which came out of the sea long after the existence of that old ichthyosaur. Now, what has happened here is convergence. These two animal forms, by natural forces, came to look the same because they had the same problem to solve, to swim very well and fast in the sea. In the same way, I think that beings will evolve, wherever life gets to this suitable complexity, who have the same need to cope with their environment as we have had, to make shelter, food, clothing, communication, and so on, and they'll be led by the same natural forces to come to all the means of communication that we have had.
Sounds very reasonable. Other planets, though, may not have the same kind of environment over a very long period. Is that possible? Could it change rapidly? Ours changes slowly to us.
Well, it will be slow on the biological scale, but once culture gets going, then this is a much more rapid scale of change. We have an example of convergence there, too. For example, if you look at early forms of writing, here are two compared, one from Central America and one from Egypt, 3,000 years apart in time and 5,000 apart in distance, and yet they look much the same. If you try to make writing, you come out with nearly the same forms.
Dr. Morrison, those are a lot of exciting ideas. I wonder if we could get Dr. Shapley over here and kind of put you two together. Doctor, would you orbit into the place here, and I'll just try to get you two angry at each other. That's not very easy, I'm afraid. Where do you disagree? You've both heard each other talk a bit. Must be some argument to start here someplace.
Well, I take a rather dim view of the value of trying to get in contact with so-called sentient beings, I'd call them, on another place, because we have so many other problems, so many other ways to spend our big monies that I would think it's a bit on the foolish side. If you could do it as a byproduct, and I think that was your idea, as weekends or something of that kind, you could turn on it, why, that might be all right.
I think it's quite clear. It's very hard to start any experiment going which doesn't have a good chance of success. This is the needle in the haystack search. I think it's a terribly valuable search, and I hope it will be pressed. But, you know, you can't expect it to win right away. So the fellows that have to do it feel concerned to go year after year, decade after decade, and no success. So I think you're quite right. It's a byproduct. Every radio astronomer, I hope, in some years' time when we decide what is the best thing to do, will commit his machinery 10% of the time, maybe, one day in every 10 or 1 hour in every day to doing this search. The rest of the time he does his own work. Then nobody feels he's made a big sacrifice, and yet the sky is well patrolled. Don't you think that would be a reasonable scheme?
Well, that's reasonable, yes.
Would you like to know, to get a message from another planet now? Would you take a chance on the information or influence it might have on our civilization?
Oh, I don't know whether it have much influence on our civilization, because the civilization is so slow catching on to advances in science. I wouldn't think but it would help out science a good deal. This is one of the big valuable things that I think you'd agree, that in attempting to get across space and here across space, we're going to find other things along the way. For instance, as we start off for the moon, we're going to find out more about the Earth. When we start off for the nearby stars, we're going to find more about the solar system. So I think there's a byproduct there also of incidental things that we may find that are valuable, even if we did take the dim view of the whole enterprise.
Surely that, but I can't believe that we will rest content until we know whether we are alone, as our theories suggest we are not.
Aren't we three fellows sitting on a bench here in a little tiny spot in the universe and saying that we are able to conceive what can be that we don't know about?
Well, we are.
Yes, but we're reasoning, I think, from some evidence. We are here, and we've heard the arguments of the atoms and the stars.
Oh, the evidence for life existing elsewhere seems to me is very strong. You agree on that, don't you?
It is very strong.
Very strong.
And I think
I understate it by 1,000,000 times. When I said 100 million, I should have said 100 million, in my own opinion. But I want to be careful in that way. And now a good many people are saying, well, perhaps half the stars in our own Milky Way system have planetary systems. Well, that's going a little too far, perhaps. But undoubtedly, we have good arguments for the believing in the existence of life elsewhere. And since there's so many stars, I believe I'll have to go along with you and say there's probably a great deal of high intelligent life, life that surpassed ours. Because you see, we aren't so very far along. We have only a few sense organs. If we had a few more sense organs, as one of you mentioned, one on radio, why, we might know a little something. But,
is it possible that they have surpassed us and been coming this way for 100 years and are here?
I thought you might ask that question.
Well, I think it's very unlikely. The travel through space is the most difficult technical project I can think of. If you wanted to send a really sizable rocket a really great distance, you'd have to use all the energy that the world musters now just to make that one trip. I don't think they'll do it. Maybe a ceremonial visit, as from one chief of state to another. But communication by electrical means is the fastest and best, as we know even here on Earth.
Fair enough.
Yes.
A man said something which is rather startling once. I would like to have, as we finish our program today, your opinion of this statement. He said, I conceive of nothing in religion, science, or philosophy which is more than the proper thing to wear for a while. In 1915, when you began to find those supernovae in Andromeda, the universe was this big. When you finished, it was a billion times bigger. Isn't that perhaps what we're wearing today's clothes and might not be changed soon?
Yes, in other words, this is a temporary situation we're in. That's what you're saying.
I'm asking you.
Yes, that it is temporary. Yes, I think so. Think what we've done towards extending the spectrum, you see, from the visual, the color spectrum, way out into ultraviolet and way out into the red. Well, tremendous advance that was in knowledge. Think what we've done with that periodic table I told you. You know, you're made of star stuff. I wanted to get that across. Or the stars are made of you stuff, if you want to be vain about it. But anyway, the same elements are all the way through. And that is one of the big advances that we hadn't done a century ago. So I think you're right. There are going to be some big ones. But where will it be?
But I don't think it will end what we know now. I don't think you'll fit elements in between.
No.
Or nor will you add anything different from the electromagnetic spectrum that we now know to the far ends. We begin to see some things, just as clothes always fit the man. So I think the clothes will change, the styles will change, but some things will remain final.
His hands and his feet.
His hands and his feet.
You know what I think is very important? That is the advance of technology, the little byproducts, accessories. I think that's where we're going to make our big advances in the future.
I think that's the next thing to do, certainly. I am anxious, most anxious of all, to see that shot between 64 and 66, when the Mars probe will land with little instruments, they call them Gulliver and Multivayor, sticking out little tentacles with sticky tape on them and trying to analyze chemically whether the vegetation on Mars is really present.
And sending back the note.
And sending back the information to us.
We'll be here and watching. Thank you very much, gentlemen.
Thank you.
Dr. Philip Morrison and Dr. Harlow Shapley, two of the people who know more than most anybody I can think of whether or not there is life elsewhere, and Dr. Shapley says 100 million to 1 that there is. And so, for this half hour, the Earth having moved during the meantime quite a bit, we will move along with it. Come again soon, please, and courage.
This is NET, National Educational Television.